The cerebellum, the small brain, again, also has two halves to it. There's a right, there's a left. It sits at the back of the head, actually, and down below the ogo, below that big one on the back of the head. That's where it sits. It is the seat for the coordination of limb functions, coordination, synchronization of limb functions. The other time I talked about how that if a child just attempted to walk for the first time, they will stagger, they will fall and get up again. At that time, they are also wiring up their cerebral hemispheres. I know in general, I already talked before how that many of the functions of the brain are kind of electrical. Well, not only are they electrical, they also... The other time we talked about how that the brain in the main is made up of three parts. See, I say in the main because that point needs to be stressed. These things are delicate stuff that we are trying to condense into manageable parcels, So in the main, the brain is made up of three parts. The cerebrum, the big brains, and then the cerebellum, the small brain. And then the anchor for both of them, the brainstem. The brain altogether controls the function of the person's day-to-day activity, conscious and subconscious level. But more specifically, the cerebral hemisphere, the big brain, is actually the seat of a person's personality. In reverse, the cerebral hemispheres are in use, the two of them, right and left hemisphere, equal halves, altogether as a single unit, is known as the seat of a human. The total self-awareness of a person's presence. Again, to emphasize, there are two halves, right and left, identical, like you have two eyes, right and left, two ears, right and left, and each looks like. And all these other human body parts that have two parts to them, two identical parts. They each can function independently of the other. Whereas the brain, cerebral hemispheres don't terribly work independently. In a way, they work less independently. They work less independently. Though each part will have its own contribution to the system that make different from that, but there's the way in which they all get coordinated. So in that sense, there are different parts of these cerebral hemispheres that take care of different specific functions of human body. Quickly also to say that even these right and left cerebral hemisphere lobes of brain are also organized into different, even on the right as on the left, as a front part, a downside to the temporal part. The front part is called the frontal lobe, the one that comes down to the area of the temple, just above the eye here in front. Temple, and then there's another part that is on the top of the head at the center there, there's parietal, and the one that's at the back, there's a part of the brain there. Each cerebral is there that sits there, that's all the lobe. So each of these sections also has different organized functions. The frontal lobe, for instance, the front part of the brain is the part where a person's real fine-tuned personality resides. The temporal part, the one right in front of the ear, above a little, the temporal part, tempo, is usually the third place where the speech resides. You need to receive speech when you have been spoken to in the language that already lands and understood. So the part that receives any talk that's been given you, any speech being made to you, where you interpret it that makes sense of it, is that part. And your response, whereas which receiving information from the environment and interpreting what that means. This is a goat in front of me. This is a plant. This is a vegetable. This is a fly. All of that is interpreted at the back part of the brain, the occipital lobe. The speech part of the brain, you see, resides in the temporal lobe. Again, it's further broken down to lobes by our scientific knowledge that it resides actually on the left side. So the left side of the brain is the one where speech resides. The motor function, the movement functions of the body, the carrying out of activities, the movement of body parts for locomotion, for manual activities, for skilled activities, they get coordinated from cerebral hemispheres. They get dictated. The thing that needs to be done, that's the part that speaks to each body part to say, hey, you need to do this. In that sense, a person may have sickness, may have infection, may have problem with a part of the brain, and the reflection of that will be that a particular function of the human body will not be for speech, for instance. When there are times when you find a person grown up, freely speaking before suddenly having difficulty with speech, to start stammering, to start not finding words, to start using names or mix things up. Sometimes that can be that, okay, in that part of the brain where speech resides as usage. One quick example that usually will happen, stroke in the layman term for the doctors, we call it cerebrovascular accidents. That means the blood pipe that goes to one part of the brain, it happens to be one that especially that goes to the speech center, something blocks it. Something blocks it, so that part of the brain is not receiving enough nutrients to get sick, if you like. Any part of the body that gets sick will stop doing what it needs to do. And how do we even get to that level? Understand? Oh, that took a long journey in human knowledge establishment. For a long time, it was not known because of other even this function resided in the brain. There were also theories that were propounded by early researchers, early workers, until, cut a long story short, cut the long distance close to home. We go to a place where it was the class would be known that actually many of these functions resided in the brain. But to be able to tell that speech is in the temporal lobe, vision is in the occipital lobe of the brain, personality, aesthetic appreciation for beauty is in the frontal lobe, and that on the right side even. That took a lot of work by what they call the cerebral localizationists. Workers in the field who succeeded in pinpointing which part of the brain carried out which function. Bones, peaks, and all that. And after a way, they started working on brains of humans that were ill, that needed to be operated for, for whatever malady afflicted them. So when they opened the brain up, in the course of their study, they will simulate, if you like, they will put an electrical spark on one part of the brain and see whether it is what function is making or what function is stopping. For instance, in a way of speaking, how did they decide that this was the part that controls speech? Oh, they were working on that part of the brain, maybe to remove cancer, to remove infection, and then because they were in that same setup, carrying out investigation of human function, they took that the opportunity of that occurrence of that session being there to develop something that can be used to stimulate each part of the brain, each part of the body, discharge an electrical current there, just put a pointer there and that fires the place up a bit. And they find that when they do that, the person stops talking. When they release it, he talks again. And they repeat that several times, it becomes obvious. The pattern becomes obvious that, it is when people have issues. And what is even more, the occasion, like I have already alluded to before, where a person may have something sitting on that same spot of the brain. They've seen the human being, he comes to them, he doesn't speak, he has difficulty speaking, the relation say, no, that just happened like 1 week ago, 2 months ago, 3 months ago, depending. And then it's been like that, couldn't talk. And then they investigate the person, they find he has a tumor, a growth, an abnormal growth or something in that part of the brain. And they open the brain up to try to take it out. And they find that the moment they finish taking that thing out, the person begins to recover their speech gradually. Then it becomes obvious. That plus other activities in the laboratory all mapped together. So, okay, this is where speech resides in the person. That's how it goes. So for different parts of the brain, for whose function we are able to tell where now, it's from those kind of efforts. One of the early workers, one of the pioneers on this subject was a man called Wilfred Penfield in Montreal University, Canada. He did a lot of work, Montreal Neurological Institute in the 19th century, early 19th century. Anyway, so that's how the function of the different aspects of the cerebral hemispheres themselves get mapped out. How did they get to know that the frontal lobe, the right, again, in the same sense, the workers in the field were able to delineate out that the right frontal lobe controls aesthetics, controls personalities, controls a bit of what makes a person to be calm, cool, collected, or to be on the excited spark. And so one way they also got around that, one of the ways, there are several ways, there are several things that got done, that got put together eventually. But one particular one that we can speak to for this moment is how people will get a little hyper excited, bordering on insanity in those days. Course of studies suggested that something has to do with the frontal lobe. And they found that if they would take that part of the brain off, they got some people who actually kind of calm down. So it then became obvious that that part of the body must be controlled. Well, the only problem with that was that when they did that to people, what we call lobotomize, then there's a way they become, if you like, down, door. So it's like the opposite end of the spectrum where you are trying to bring a person. It was too much. You thought you should bring him down. And you took him to the other end. So, but altogether, that's how it is that we get to be able to tell different functions or different parts of the cerebral hemispheres in a way that we can make it come to general public. There are hard scientific work at heavy levels that arrived at this place before man arrived at this junction. But if we must synthesize and bring it to a layman, this area can attempt to do that.
Travel beyond limits. Nothing required from you except your bags. From Nigeria to zero travel limits. DigiFly beyond limits.
The cerebellum, the small brain, again also has two halves to it. There's a right, there's a left. It sits at the back of the head actually and down. Below the ogo, below that big one on the back of the head. That's where it sits. It sits for the coordination of limb functions. Coordination, synchronization of limb functions. The other time I talked about how that if a child just attempted to walk for the first time, they will stagger, they will fall and get up again. At that time, they are also wiring up their cerebral hemispheres. I know in general, I already talked before how that many of the functions of the brain are kind of electrical. Well, not only are they electrical, they're also chemical. Chemical, electrical, internal. Interlocking, sometimes electrical signals, chemical process to happen. Sometimes chemical process is the one that tells electrical activity to happen. So the cerebral hemisphere is much about electrical activity of wiring of things, laying down cables, if you like. And it has to be first laid down. Each new activity a man wants to learn to do must first be wired, if I may say. Which is why you find you don't just attempt a skill, playing piano, playing guitar, riding bicycle, doing high jump, playing lawn tennis, playing table tennis. You find that you don't get it right the first time, but when you practice, you get perfection. Okay? You get precision. The season of your practicing, you were wiring your cerebellum, if you like. You were wiring them up, laying the cables to be able to, achieve that synchronized function that you are aiming at. And it's a two-way communication. If anybody may get confused and say, but we said before that it was cerebral hemisphere that control what you do. Yeah. The cerebral hemisphere is the conscious place, is the control system, control panel, the brain box. Well, the brain box is the place where the thing that needs to be done is dictated. But that the performing needs to be executed by the coordination of the muscle activities that go into it by the cerebral hemisphere. The cerebral hemispheres are the one who do that. So they need to communicate with the brain. Hey, what's it that you want us to do? This guy. The brain says, you know what? I'm a man now. I want to learn to swim. I want to jump in the water. When you jump into the water, they say, well, you have to flap your arms, flap your legs. If you are going to stay afloat, you're going to not go to get it right the first time because your body is not yet used to the synchronized flapping of hands and legs. Not at the first time. But the brain knows the target it wants to achieve. He's sending that message to the cerebellum. The cerebellum is achieving, oh, that's what you want. Okay. So when you now want to tap flapping your arms and legs in the water, you'll be doing what you are doing. You'll not be getting it right. You'll be sometimes crumbling, want to sink. They say that information is getting back to the brain to tell the brain that you are going to sink. But before it gets to the brain, it passes through cerebellum first. So the cerebellum also received the information of the fact to understand that, okay, you're not flapping the right leg well, you're not opening your arms well, the elbow is too stiff in that side. So the cerebellum has to first receive the information of what needs to be done and has to also now receive what's been done and see how well it's meeting the target or not. Again, how did they come about that is the same concept. For a long time, it wasn't known that that's where the seat of that kind of activity resides. But with scientific study in the labs, in the clinics, in the operating room, it became obvious that this must be the part of the body, even the part of the brain, where this kind of function is observed. It coordinates the activities. Which is also why anything anybody wants to do, there's a sense in which, and I'm a bit guilty of that too, there's a sense in which when we want to start a new skill, a new something, because you've seen the master at it, doing it effortlessly, you imagine that you two should just pick the thing and it should flow with you that time. And then when it doesn't flow, you're wondering, you won't get it. Well, you don't know that so-called master also had a season when he was busy wiring his brain up. But that was out of your view. As a rule, you don't see when the master is training. It's only when he comes out to perform that you see him and then you think what he's doing is much. It's not much. There's a season of working things up, laying the foundation, wiring things up. You first need to, your body has to get used to it. Your muscles have to get stretched. Your muscles have been stiff in a particular direction before. Now the thing you're asking them to do now, they need to stretch to reach it. Now they have to, all of that needs to be done. So always just know that you first have to train the cerebellum has to be trained, has to be informed what needs to be done. And it has to then achieve precision. In fact, one of the ways we know when a person has problem with cerebral function is we say he will pass point. If you gave him a target and say he should point at it, a person without a cerebral lesion will go straight for it and a pinhead will put his finger on the pinhead. That tiny thing, he will reach that target easily. But a person with cerebral dysfunction, if you say for him to reach the tip of your nose, misses, reaches your eye here, reaches your eye, he passed points. He passed points. He cannot walk on a straight line. He has difficulty coordinating the activity. Well, of course, that's not about only the cerebrum, just that specific aspect of it, it's cerebrum coordinating all of those functions. It's at a subconscious level. You don't inform the cerebellum, get my fingers to work well on the piano. No, it is the cerebrum, it's the big brain at the conscious level that tells the aim that you want to learn how to play piano. And then you put your fingers on the piano. And you begin to wiggle the fingers. Well, how do they get coordinated and deliver the precise motion that gives the tune that you want to hear? Well, that has to do with the coordinations of activity of those small parts, all of them brought together in synchrony by the wiring in the cerebral hemispheres. That's how that happens. Yeah, we talk about, we said there were different main parts of the brain. Okay, three main parts of the brain. The cerebral hemispheres, the seat of the whole person's totality. The cerebral hemispheres that coordinate the activity dictated by the big master, the cerebrum. The brainstem is the one that actually connects each to the other so that they can tell and receive and respond. That brainstem not only does that, it actually is also the one that eventually connects the whole of this brain inside of the skull, inside of the head, to the rest of the body. The connection happens being the stem of the brain, the cerebral hemispheres, needing to bring in information from the outside and needing to send information from the brain onto the outside. It connects with the rest of the body through the spinal cord. So that spinal cord, and actually, if you like, and the brainstem are actually the same structure that different levels take on different name, different function, and different structure. So the brainstem is housed inside the head, but reaches out beyond a hole at the base of the head to connect with the spinal cord, so that information being received from the outside will travel as they come through the spinal cord. They will then travel through the highway of the brainstem to branch at the cerebellum and drop some hints here and there, and to go straight eventually to the cerebral hemispheres and discharge all the significant part of the information that they're carrying. So there are two-way traffic, to and fro. But beyond that, they actually subserve much of the functions that we said were at the subconscious level for brain. It's a part where living resides. Being alive. Okay, being alive. You have to be alive first before you think. You have to be alive. A dead person doesn't think. And so for that reason, the brainstem is said to have centers, different centers. Vasomotor center, reticular activating system, cardiovascular center, respiratory center. By which you mean there's a center in that brainstem that pulses regularly, non-stop, at the subconscious level to speak to your breathing, that you keep breathing. So how do you get sometimes to raise your breathing and breathe fast and breathe slow? Well, that comes about from demands of your body system for more work and also occasionally from your brain cerebral hemisphere to tell the brainstem. The cerebral hemisphere, again, is the master orchestra, is the master of the orchestra somewhere sitting there and telling the brainstem occasionally, okay, raise things up and down. But beyond that, the brainstem works autonomously, coordinating the breathing. It does the exact same thing for the beating of the heart. It does the exact same thing for wakefulness. It's one thing to fall asleep. It's another thing to wake up. Or better still, it's another thing to be in coma. Coma means the whole of the brain, including the cerebral hemispheres, has stopped working. But a person can wake up from that same coma and have his eye open, be looking at you, and not be responding to much. That person is being kept alive by the brainstem. That brainstem is making the person alive. You don't say it's there, yeah, it's looking at you. But it's not performing for you because the cerebral hemisphere is not yet recovered. The cerebral hemisphere is not dictates, okay, you've slept for several days. Now you are woken up. We see you. Your eyes are open. Get out of bed now. Well, talk to us now. No, he doesn't do that. He's not able to do that because the cerebral hemisphere that takes care of those fine functions is still sick. But the brainstem, to the extent that the brainstem is still ticking, the person will be beating. Breathing will keep taking place. But my tissues of the body are being supplied with their nutrients from the heart beating and the respiration bringing oxygen in. So the person is alive, not dead, only that. It's not his full person yet because the full person comes from cerebrum. So that's the function of the brainstem. It does all of those kind of activities, even though it is subjected to control of the cerebrum. And some of the ways it gets to carry that out is in that center. Okay, that center they are in the brainstem that we say there are centers that are sit down there and are controlled breathing. But how does the center in the controlled breathing in the brainstem? How does it reach to tell my lung to breathe or my heart to breathe? Quite apart from the fact that there are also pipes, cable lines within that brainstem that goes through the spinal cord and goes down to the level of the heart and then supplies nerves. For the head in particular, some of the functions that the brainstem performs also includes some of the functions of the head and neck, of the face, of the mouth, saliva, spitting, smelling, hearing. These ones are subserved. The saliva, making of it and spitting and swallowing if you may, and then swallowing. How do you do that? That happens in the throat. How does the brainstem get to be able to tell them what to do? How does he send message to them? Well, he sends message to them through what we call nerves. Actually, all of the nervous system, the brain, whether cerebellum, whether cerebrum, whether brainstem, we say they control the function of the rest of the body. The brain, for instance, controls the movement of my toes. If you tell me to wiggle my toes now, I wiggle it. I'm telling you that it's the brain that commands that. So how does the information from my head get to the toes? That information travels down the spinal cord, then the brainstem, reaches the spinal cord, moves down and not the spinal cord to the level where the function of the toe will reside. And then from there, a nerve takes off, an electrical wire takes off and goes through my body, down, till it reaches the toe, gets some branches, tiny branches that it reaches the toe. It is from there that the information goes to my toe. Also information from my toe reaches my brain in the reverse direction. That's how back and forth communication takes place. So the brainstem subserves much of its function by nerves, what we call cranial nerves of the brain, if you like. Because indeed, there are nerves in all parts of the body. And there are several of those. Those are many. Whereas for the head and neck place in particular, there are nerves that supply hearing function, that supply swallowing, taste function. The brainstem sends nerves to those parts also to go collect information. This thing you put in your mouth, is it salt? Is it sugar? Is it bitter? So it's from these cranial nerves of the brain area. Because there are other nerves that are not of the brain area, that are peripheral nerves on the surface. Those are the ones that take care of all the other parts of our body, the arms, the legs, the chest, the abdomen, and whatnot. So the brainstem sits as the anchor of the big brain cerebrum to the small brain cerebellum and the pathway to and fro between all of the brain system altogether and the rest of the body in particular, especially for some of those functions we see happen at the subconscious level. If there be any part of this that you like us to also now expatiate on later, or that you like to also look at in another way, please drop your comments in the chat box. Thank you so much.